This video covers migrating a .NET Framework-based Umbraco installation to a .NET Core-based Umbraco installation. The last .NET Framework version of Umbraco was version 8, so we'll migrate a version 8 Umbraco site to the current latest .NET Core version, which is Umbraco 13. The migration is achieved by first migrating the Umbraco 8 database to a .NET Core-based version of Umbraco, i.e. Umbraco 11. The database migrations are performed using blank Umbraco CMS projects for versions 10, then 11, connected to the Umbraco 8 database to upgrade it through successive major versions of Umbraco. See the separate database migration video in the description. After the database migration is complete, each .NET Framework project in Umbraco 8 solution is migrated to Umbraco 11, which uses .NET 7. Blank .NET 7 code project is created in Visual Studio and the code copied into it to begin the migration. An Umbraco package project is created for each plugin migrated. With the Umbraco 11 migration complete, NuGet packages are simply updated first to Umbraco 12 and then to Umbraco 13, which targets the .NET 8 framework. .NET 7 target framework must be updated to .NET 8 in the Visual Studio project files. A demo of the migrated site is given and some sample code is listed. The migration covers the issues and solutions for migrating the various types of projects in the sample site used for the migration. The Umbraco CMS project, plugins, components, property editors, content apps, and class libraries. Some general migration tips are listed. A new project was added to the solution for the models. In Umbraco 8, the models DLL was built by Umbraco on the fly. Now it is built in Visual Studio from the source code for each model. I try to avoid using third-party dependencies as they can cripple a migration, especially if they've not been migrated themselves. So in this migration, third-party dependencies have been recoded in-house, e.g. the auto-content generator and menu management. The other third-party dependencies have been dropped, e.g. a color picker. The general migration approach has been to migrate the database first, then use Umbraco templates to create empty projects where the .NET Framework code is copied into. A global change to namespaces and all projects is required. Config files are migrated to JSON files and mapped to strongly typed iOptions types that can be injected into the dependency injector container and accessed throughout the app. HTTP context current is a popular property used in the .NET Framework, but it's not available in .NET Core. But with a little manual coding, this is reintroduced in the migration to avoid refactoring some code. The global error handling used to be done in the global ASAX file, but this is not available in .NET Core. It is now implemented as an error controller with the error route a reserved Umbraco path. Content pages for each of the error codes are created in CMS, e.g. 500, internal server error, 400, 401, etc. The default 404 not found page is configured in the app settings Umbraco config file. Google's mail server is used to send email from the global error handler and contact us pages. This now requires an app password to be set up to work under the Google account used. The migrated solution is hosted in IIS, which requires the ASP.NET Core module to be configured for it, and permission for the app pool user needs to be given to the publish folder and the modules folder. Services in the dependency injection container cannot be injected directly into class libraries when instantiated directly within code. The workaround for this is to have a static service provider that then used to get the required services from inside the methods in the class libraries. The common practice is to release all project DLL versions with the same version number. This is now done by configuring the version number in the directory.build.props file located in the solution directory instead of in a common assembly info file. The server variables collection is no longer available, but many of these properties can be found implemented in general.NET Core types, e.g. the remote IP address. Migrating the Umbraco CMS raised a number of issues. CSS and JS bundling used to be done by the client dependency framework, but it's now done using the smidge package that's built into the Umbraco installation. And when you use that, use caching based on a configured version number. All CSS and JavaScript files bundled from partial views were merged into the master layout template bundles. Otherwise, they'd be excluded from the bundle. All helper methods had to be recoded as code blocks. Members are accessed by injecting the member manager into Razor files and any other services that you need. Surface controllers no longer support child actions, which are now implemented as view components. Ajax forms had to be re-implemented using the form tag Ajax attributes. API controllers have the scope provider injected in order to pass it on to the repos accessing the database. All script tags using the tilde lead were added to some bundle in order to be resolved in Visual Studio debug mode using IIS Express. If this was not done, IIS Express expect to find them in the content route instead of the web route. All plugins were migrated in a similar manner, starting with an Umbraco package project. Plugin migration had the following issues. The current scope provider no longer exists. Instead, the iScope provider is injected into the API controllers. The tree controller has a new interface, but essentially the same code body. Package database migration upgrader had an updated interface, but essentially the same code. The Umbraco CMS project file is edited to add an import element for the plugin to ensure when the CMS project builds, it pulls in the app plugin directory for the plugin. The plugin package manifest and its references are built using Gulp. That works the same as in the .NET Framework project. Composers and components were migrated to notification handlers. These handlers had the required services injected into them. The handlers also needed to be registered in the startup file of the Umbraco project. Most editors no longer have access to the JavaScript serializer, and they use a JSON serializer, which is slightly more cumbersome to use. The Umbraco content is also accessed in a slightly different way, e.g. the publish snapshot is now accessed via a method rather than a property. Content app migration requires services to be injected instead of relying on static access. Some Umbraco features like the Umbraco helper no longer exist. The equivalent services need to be injected. Some display formatting tweaking was also required. Okay, here's the migrated website. We can see it's now Umbraco version 13.03. This page is an example taxonomy, a content app plugin that basically shows you which pages the tag is used on. We can see that we've got three plugins. One is it's going to be a commerce site for books, and on the front end it will list the books that you can add to your basket. Another one is a survey where you create surveys and assign questions, and then on the front page you can fill in the survey and then see a report of all the answers to the questions. Then there's general utilities. I have a subscriber page that people can subscribe to. They want notified on their Windows desktop about new videos, and any subscribers will appear here. The other general utilities like you can add feedback questions, you can add comment sections that comments get sent to the development team and they can review and so forth. Other utilities in the plugin support the likes of adding widgets to dashboards and editing those features. And other scripts and CSS have been bound into the Smidge bundle, so you'll see them on here. And on page with its various features, buying a copy, chat, which uses the external source. There's also a Migrate store plugin, and that completes the migration. This is the migrated project in Visual Studio. All the projects here, we have the content management system. We've got plugin sections. We've got taxonomy for the content app. We've got the Umbraco models. We've got general helper libraries. We've got some error page generators and auto content plugin as well. You can also see that for the plugin sections we use Gulp, and then we generate tasks for build and release and setting up the plugins. Thought I'd show you some code samples. I'll start with the app settings JSON. A couple of things we've done in here. The error handler, we've reserved that path for the error controller. The 404 not found page is configured. We choose to use source code manual for models, and we give it the directory of the project we've just seen, and we use this smidge for CSS and JavaScript and time minification, and find the version option most useful. And normally each time you add new CSS or JavaScript, just increase the version. In the program, I've manually added the JSON files that I've converted from config files, just so that we can access them in strongly typed types. In the startup, you can see that you can configure those JSON files as strongly typed options, environment secret options. Also, we add our notification handlers into the configured services. We also use our own replacement for the global ASAX exception handler, and we give it the root /error. We set up static HTTP context, and we make the dependency injection container static so it can be accessed from anywhere, particularly from class libraries. The error controller, we just configure the root and we process the error. In my case, I send email to support and redirect content pages based on whatever the error code is. And we also use a bit of middleware to support these errors occurring within the system as well. And we use a static service provider, so we configure that as a static so that we can pick up any of the services from any class library using the get service. That's useful for pulling out the config files within DLL methods. We also use static HTTP context, and in here we use the same namespace as in .NET Framework, so system web, HTTP context, current, and that keeps namespaces the same important code, so you won't have to change that. That allows HTTP context current to be used in your migrated code. Elsewhere in view imports, we add our own namespaces to avoid having to add them anywhere, and the plugin package manifests in the one version numbers just so they show up in the back end, and it's the usual configuration for your plugin dashboards, JavaScript and CSS files, and that completes it.